This is the help video for the take-home practice quiz 2.1 to 2.4, the ALEKS section. So we have problems 1 through 10, sample problems here. And as I explain this, if you're like, oh, I know how to do this, just do a little check mark there saying I skipped this because I know what I'm doing. Otherwise, I'd like you to read along with me with your finger on the screen following the red dot. Ready? Question number 1. The point T is the midpoint of SV. Find the location of S. So we have a segment here, SV. So here's V. And if T is the midpoint, then it is the middle of a segment. So I'm going to draw it so it looks like a middle. So S is somewhere over here. And the question is, where would S be? So by definition, midpoint means middle. So I figure out how many bunny hops are between 15 and 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 bunny hops. 6 plus 9 is 15, which means there's 9 bunny hops this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I'm starting at 6 and I go 9 this way, as coordinate is going to be -3. Coordinate means position or location, coordinate or location. So the location of S is -3. Says in the figure below, S is between Q and T. I'm just going to highlight between Q and T. So here's QT, and S is between. Between does not mean middle. Very important. It just means it's between somewhere. And R is the exact midpoint of QS. So I'm going to trace QS, and I'm going to circle R, midpoint. And if that's the case, that means Q to R, R to S. I'm going to use brackets, is hatch marks. Took care of all of this information. R to S. R to S is 8. And Q to T all the way is 19. Now, ALEKS is going to want you to find a specific something. In this case, it's ST. Warning, on my quiz, I'm going to ask you to find everything possible and mark it on the diagram. So just be aware of that I'm going to go far beyond just what ALEKS requires you to. ALEKS is just practice. But what you should notice, get your fingers on the diagram. Fingers, put your fingers right here. That's 19. If this is 8, this is 8, which means from here to here, fingers on the diagram, you should be able to feel it is 16. And then you go like this, 19, 16, 19, 16, 19, 16. And that gets you the 3. All right. Next one, we read, figure below, G is between E and H, and F is the midpoint of EG. FG is 2, FH is 6. Find EH. So first we have G is between. G is between. Now careful there. It looks like G is a midpoint, but it is not. It just says between. F is the midpoint of EG. So F is the midpoint here. That means E to F and F to G are going to be the same. If F to G is 2 and F to H is 6, it wants you to find E to H, which is the whole thing, of course. My test, I'll make you find everything. So if this is 2, that's 2. That 2 away from 6, that's 4. This is 2 here. 2 plus 6 gets you the whole thing, which is 8. Finger on the screen, out loud, read. Calculate the distance between the points C and -3, 4 and 2, L at 2, -2 in the coordinate plane. Give an exact answer, not a decimal approximation. So first we graph our points, and C is over 3 up 4. So -3, +4. L is to the right 2 and down 2. So here's our segment. Distance equation. Distance equals giant square root. There's your template. Subtract square, subtract square. I'm going to circle the x's. And when I plunk them in, I'm going to draw an arrow so I am consistent in the direction in which I subtract. A lot of students get confused. Do I go left to right, right to left? Doesn't matter. What does matter is whatever direction you start, you finish. Now, this is square root of 29. On my test, I expect you to factor, if at all possible. But because 29 is prime, there's no dates, so it stays root 29. That would be the correct answer. Now, if you had something like root 28, I'd expect you to factor it out, pull out your double, and 2 root 7 would be your final answer if your answer was 28, root 28, but your answer is root 29 here. Number 5. As it wants you to find the midpoint of the line segment. A is at -7, +6. B is at -1, -2. So A is at -7, +6. B is at -1 and -2. Add the x's, divide by 2. Add the y's, divide by 2. I'm going to circle my x's. I'm going to plunk them in left to right. Box my y's, plunk them in left to right. So my midpoint looks like it's -4, 2. Let's check it on the graph. 1, 2, 3, 4. 1, 2 would be about right there. And what's really nice about this, when you graph it, it actually looks accurate. It said the midpoint of A to B is 1, 2. A is sitting at -2, -2, and B is at unknown X and Y. All right, there is a algebraic way of doing this, and there is a logic way of doing this. I call it the grammar problem. I'm going to show you the algebra so you can appreciate the shortcut when you see it. We know that if you add the x's, divide by 2, you get the x midpoint. Add the y's. Divide by 2, you get the y midpoint. Now, in this case, you have the midpoint. So our midpoint answer here is 1, and our midpoint answer here is 2. We go like this. Negative 2 plus an unknown x divided by 2 equals 1. Negative 2 plus an unknown y divided by 2 equals 2. To solve, I'm going to cross multiply. And I have 1 times negative 2 plus x equals 2. Negative 2 plus x equals 2. Add 2 both sides. And our x equals 4. This way, cross multiply, I have negative 2 plus y equals 4, plus 2 plus 2, y equals 6. So that gets us our endpoint, 4, 6. I think doing it algebraically, an easier way to think of this is I know I have to have equal distance or equal numbers between. So from negative 2 to positive 1, there is 3 units. So from 1 to this x must also be 3 units. So 1 plus 3 is 4. From negative 2 to positive 2 is 4 units. From 2 to unknown number must also be 4 units. 2 plus 4 is 6. Therefore, it is 4, 6. As you can see, you get the same answer. 1 seems to be a shortcut. That's 6, 7. Find the slope of the line. The slope, let's define it, is rise over run. Here's your template. My rise goes with the y's. So I box my y's. Left to right, I'm going to plunk them in. I circle my x's, left to right. Double negative makes a positive, that's 9. And negative 4. Excuse me, not negative 4. 2 minus 8 is negative 6. And say it out loud. So that's positive 9. 2 minus 8 is negative 6, which you can reduce. 3 goes in there 3 times, 3 goes in there twice, and it is a negative 6. Y minus y over x minus x. Let me down here. The equation of the line is below. Find the slope and the y-intercept, and then you will be required to graph these. So negative 12x minus 3y equals negative 9. You want to get y by itself. So you work away from the y and you get closer and closer to the y. You don't bother with the 9. The 9's already in the other room, as I say. So you're going to add 12x, add 12x. Negative 3y equals 12x minus 9. Divide by negative 3 to get rid of it. Take it over to the other side. So I have y equals 3 goes in there 4 times. It's negative, so it's going to be negative 4 over 1x. Double negative makes a positive, plus 3. Now, to graph this, my b is positive 3. That's your y-intercept. I know that's a negative line. So at that, I go down 4, 1, 2, 3, 4 over 1. Or I could go up 4 over 1. And there's your line. So you isolate the y, you identify your b and your slope. We're going to graph the line, and we are using, in this case, point slope form. So we write out point slope, y minus y1, slope x minus x1. Our first order of business is to find your x1 and your y1. Look very carefully. In the original equation, right there, x1, notice the sign did not change. Because the sign did not change, the 2 had to be positive, because if you stick in a negative 2 there, it would flip the sign. So my x1 is going to be a positive 2. My y1, careful, notice the change in the signs. If the signs change, that means we had to stick a negative 3 in there, because double negative makes a positive. So that goes here, negative 3. Our slope is right above it, is negative 1/5 rise over run. You know it's a negative. So you start at this point, positive 2. So 1, 2, down 3, 1, 2, 3, positive 2, negative 3. Then you count your slope. I'm going to rise 1, run 5, 1, 2, 3, 4, 5. This one, the line passes through the point we want it in. So it passes through this point, and we want it in standard form. Standard form is a whole number x plus or minus a whole number y plus c. So because I have a point, x1, y1, and a slope, I'm going to use point slope form to begin with. So I have y minus y1, slope x minus x1. Now plunk my x there, which is 6 and 1, and my slope is 5/2. Y minus equals parentheses x minus. All right. Now, at this point, I am going to distribute, and we have y minus 1, 5/2x. I'm going to take it in the margin, 5/2 times 6. 2 goes into 6 3 times. 3 times 5 is 15. So that's going to be minus 15. We keep going here. We need to get the x over to the other side. Now, here's a little bit of a trick. It says right here we're to use integers for a, b, and c, not whole numbers, integers, so no fractions. So at this point, to get rid of that fraction, we have to do arrow in, arrow out. So remember when we do arrow in, arrow out, the first step is to make everything a fraction. We have one fraction here. To make a fraction here, I need to pop it over 1. To make a fraction here, I need to pop it over 1. To make a fraction here, I need to pop it over 1. Now, big parentheses, my LCD, I have a 1, a 1, a 2, and a 1. So my LCD is simply 2. Arrow in, arrow out. 1 goes into 2 twice, little baby 2. This becomes 2y. 2 goes into 2 one time. That's going to be equals 5x minus 30. All right, we want our x's on one side and numbers to the other. So I'm going to minus 5x. And look at the form we want here. We want x to be first. So it's going to be negative 5x plus 2y minus 2 equals negative 30. Add 2. Final answer for this one, negative 5x plus 2y equals negative 28. So we want our x and our y on one side, strictly a number on the other, and the preceding numbers to x's and y's need to be integers. So you must use arrow in, arrow out method.